All right, guys, you recall that in our last class, we showed how to find the resultant of two vectors for any two vectors. Okay, now I will now show you how to find the resultant of more than two vectors. That is when the vectors are more than two. So look at it. But before I go further in this, I would like to tell you guys about component of vectors. Component of vectors. Now, what is a component of vector? The component of a vector is the effective part of the vector in a certain direction. That is what a component of a vector is. Now, remember the effective part of a vector in a certain direction. So now, this is a vector. Let's say this vector is A. Now, this A has component. This is the horizontal component X. This is the vertical component Y. Okay. Now this is the angle. Okay. Now this is, remember, this is a right angled triangle. Now to find the horizontal component, so in fact, let me just call this one AX. Let me call this one AY. Okay, because they are components of vector A. Now to find the horizontal component, you recall from trigonometric ratios. That is cos theta is equal to adjacent over hypotenuse, which is what? AX over A. Therefore, AX is equal to what? A cos theta. That is the horizontal component of this vector is what? A cos theta. That is where this vector has effect along horizontal direction. Now, as for the vertical component, we have sine theta is equal to opposite over what? Hypotenuse, equal to AY over A. Therefore, AY is equal to what? A sine theta. So, the component of this vector A, this vector now, this vector in the vertical direction, this side, the component is what? A sine theta. See, the thing is, at times it's good if you are studying physics, you need to like use real examples, or you use your imagination to imagine a real example. That is a scenario where these things are being applied. Now, take for instance, when you were young, that time you used to construct a car, a toy car. Now, this is the car you constructed. This is the car here. You constructed this car when you were young. Now you are using a rope to pull this car along a horizontal direction. So now this is the rope. So this rope is inclined at an angle theta. Now watch. If you recall, like if you are observant, anyway, you are let's say that time you are not used to physics, but physics is in you. But let's say that time you are not used to physics, but now that you are used to physics, now if you pull this rope up, like if you are increasing the vertical component, do you know what will happen? This car, so at a point, the tires will not be touching the ground again. It will be lifted up. Do you understand? But when you are increasing the horizontal component, that is when you are bringing this rope down. You are pulling it along. If you are bringing it down, that is thereby decreasing the vertical component and increasing the horizontal component. You know what will happen? The car will be moving very fast along this horizontal plane. Do you understand? This is one application of the component of vectors. Do you understand? That is one scenario whereby you will really understand what we mean by component of vectors. When the horizontal component is being increased, that means the force you applied will be what? Increasing. I hope you know that it is the tension on the rope that is pulling this car. Like this, the rope that you are used to pulling the car, it has what? The tension. Do you understand? A force we call tension. Okay? Tension force. You are applying force, but if the rope doesn't have any tension, of course, this car, it will just break. Do you understand? Or it cannot pull this car along the horizontal direction. Now that you have known what components are. So I will now introduce how you add, like how you find the resultant of more than two vectors using this idea of components. Okay, so that will be in my next video. So see you in my next video.